For this tutorial, I want to take a look at a seemingly easy chess piece to model in order to discuss the problems associated with modeling a rook chess set piece and some solutions associated with that. So I've got a rook reference here in our scene, and again the body is fairly simple, lathed object from a spline. So I'm just going to talk about the problems associated with the crenellations on the top of the rook. The problem with a shape like this is that while it does seem simple, and in reality is a simple shape to create, when you apply a subdivision surface to it, there are problems associated with the rounding and tightening of the edges here on a curved surface. If the shape was a flat surface, then the problems are not present, but with a curved surface, subdivision surfaces can provide a problem with smoothing. So let's just look at the situation that we encounter. So I'm going to start out with a cylinder, of course. Not going to model the whole body, no need to do that, but in order to illustrate the problems associated with this, let's start out with a cylinder that is only, say, 18 segments in order to reduce the amount of geometry. So we'll start out with a cylinder of 18 segments, make it editable, optimize it, and for the sake of simplicity, I'm going to remove the lower polygons, select the upper polygons, inner extrude with tapping I to create the geometry that we will need for the crenellations here around the top of the piece. And then I'm going to also at this point just push this down a little bit to provide a little bit of a lip right here, because although this one doesn't have that, most rook pieces do have a indentation here below the crenellation itself. And so we'll drop that. And then looking from the top view, we'll select appropriate number of polygons, 2, leave 1, 2, leave 1, 2, 2, 2, and 2. So now we have even number of polygons selected. Deselect that one. Then with control drag, we'll just drag up the crenellations like that. Now everything so far is straightforward and very simple. But as soon as we start to bevel the edges here, that's where the problems begin to occur. So let's use loop select and edge mode. We'll select relevant edges that we need. So we want to select all these edges. Then in addition, select the edges on the inside corners here. So orbiting around your model, being sure to select all these relevant edges that need to be beveled. Making certain that you're only selecting visible elements, so you're not inadvertently selecting more than you want. Then in addition, selecting this inner edge, and then we'll bevel that with 2 subdivisions, should be enough for nice rounding. Drop the tool, take a look at it, and looks pretty good at this point. Then we add our subdivision surface, and we begin to see some of the issues that arise. And that is, as you can see right here, in these corners you get a definite pinching taking place right there, deformation of the surface. And that's what happens on these curved surfaces when you have corners like this that are then beveled. The problem with applying a subdivision surface is this pinching. You can see it's happening on the inside as well. Now for something quick and dirty, that might be okay, but even from a distance, that's still a problem here. And that's a consequence of the curved surface. So if we dismiss our interactive render and go back to just the cylinder, the problem is here. And that is an unfortunate kind of tension is created in this n-gon space. So let's see another solution to this. So we'll go back to our original selection and we'll select these edges at the base of the crenellations along with all the others that we have already selected. Selecting those all the way around, and then likewise on the inside dismiss my manipulator widget there, selecting these on the inside also. We bevel it with the same bevel parameters, add a subdivision surface, and take a look at the results. Now we can see that the pinching has been reduced here on this, on these outside surface, but it's still there. You can still see some pinching. As you move away from it, you can see right along here some unacceptable pinching, and then the same problem is occurring inside here also. So that's the problem, and it becomes a very difficult one to resolve. The resolution, for the most part, comes in adding more geometry to begin with. So instead of an 18 segment cylinder, let's do the same thing here. We'll take a look at a 24 segment cylinder. Okay, so more geometry, beveling it just like we did before. Add our subdivision surface and take a look at the results here. You can see that the result is better. It's cleaner, but still some pinching occurring right here in the corners, and still some problems back there on the inside curve as well, where that corner is created in the back. And so still a problem that isn't completely solved. So let's look at one more example. We'll hide that one and open up this one, which is 36 segments. So here we have a 36 segment cylinder. Let's turn off the subdivision surface temporarily. So more geometry in this case. We've done the same beveling process as before. So let's turn on our subdivision surface and take a look at this render. Now we can see that the edges are cleaner, much cleaner, both on the outside and the inside. Now notice that on the inside we still have some pinching right here, but it's not as bad as it was. So the solution to this type of a design here with our Rook Crenelations, with these inside corners on a curved surface and subdividing that surface, is to add more geometry. So you try to find an acceptable solution between smoothness versus excessive geometry. Now another thing to keep in mind here that can help. So I turn subdivision surface off and let me select this edge and dissolve it. Subdivision surface back on, turn that back on again. It can be that adding some edge loops, not up close because it'll cause a little deformation up here, but down here in the body of the top of the rook will help to sharpen up this edge right here, because as you can see, this gets pulled down a little bit too much right here. Got a nice crisp edge here and up here, but when you compare this edge to that one, you can see that it gets pulled down a little bit too much right there. So let's add, in our loop mode, just add a loop in here and take a look at the results, and you can see that now that is tighter. So adding this edge loop down here in the body of the mesh gives us better results up here. So now you look at this edge, it's comparable to that one, and everything is looking much better. So that's the solution then to creating a successful rook for our chess project.